Hello everybody. In our previous lecture we have discussed introduction of finite automata, okay, with the help of one example. Okay, so our today's topic of discussion is classification of finite automata. Okay, and in this session we will just discuss one more point, that is definition of DFA. DFA stands for deterministic finite automata. Okay, see, in our earlier session we have discussed introduction of finite automata, and along with that we have discussed when to say input string is accepted by finite automata or input string is rejected by finite automata. Okay, with the help of example in detail we have already discussed this particular point in our previous session. Okay, so I request you all to please do watch our previous session first, okay, and then proceed with this one. Okay, I'm assuming here that you are comfortable with this particular point. Okay, that is when to say input string is accepted by finite automata and when to say input string is rejected by finite automata. Okay, so by considering this particular point, let us proceed with next concept. Okay, so as I said earlier, our first topic of discussion is classification of finite automata. Okay, see, this finite automata is mainly divided into two types. Finite automata is mainly divided into two types. Okay, first type is finite automata with output. Okay, and second type is finite automata without output. Okay, then see, this finite automata with output is further divided into two different types. Okay, so first type is Moore machine. Okay, MOORE, Moore machine. Okay, and second type is Mealy machine. MELAY, Mealy machine. Okay, as far as finite automata without output is concerning, this finite automata without output is further divided into three different types. Okay, so first type is DFA. Second type is NFA. Okay, and last type is epsilon NFA. I hope you are familiar with this symbol, epsilon. This is a Greek symbol. Okay, so here DFA stands for deterministic finite automata, NFA for non-deterministic finite automata, and last one is epsilon non-deterministic finite automata. Okay, so let us revise this particular point. Our main topic of discussion is classification of finite automata. It is divided into two types. First one is finite automata with output, which is further divided into two types, that is Moore machine and Mealy machine. Okay, and second type of finite automata is finite automata without output. Okay, which is further classified into three types. First one is deterministic finite automata, then non-deterministic finite automata, and finally epsilon NFA, epsilon non-deterministic finite automata. Okay, now see, now out of all these types, we will just proceed with this one first, DFA, deterministic finite automata. Okay, actually see, whatever example that we have discussed in our previous session, that diagram, if you remember, that diagram is a diagram of deterministic finite automata, and in this session also, with the help of same example, we'll try to define this particular concept. Okay, that is deterministic finite automata. Okay, so let us start with the definition of deterministic finite automata. DFA, deterministic finite automata. Okay. Now see, before proceeding with actual definition of deterministic finite automata, I just want to draw same diagram which we have already discussed in our previous session. If you remember, see in our previous session, we assume that we are having input alphabet sigma, taking two symbols in it, small a, small b. Then in our previous session, we assume one language. Okay, that language was the language which contains all the strings which starts with A. Okay, so A, AB, ABB. Okay, so AABB. Okay, ABBB. Okay, and so on. So in our earlier session, to represent this particular language, we have already drawn deterministic finite automata. So same diagram I want to draw here. Okay, so that it will be easy for you to understand this particular point. Okay, in a more in a easy way. Okay, so in this case, see here, we have discussed this diagram in this way. So here A, then A comma B. So A was a initial state. In our previous lecture, we have already discussed the introduction of this particular diagram. Okay, so C, and here A comma B. Okay, so that's why what I'm saying, if you have not yet gone through our previous session, then please do watch our previous session first. Okay, and then proceed with this one. So in last session, we have discussed point that circles are called as states. Then if before circle this type of arrow is there, then that is called as initial state. If circle within circle will be there, then that is called as final state. This is called as loop. So you just revise all those things. Okay, and then we have discussed how to check whether this DFA accept given input string or not. Okay, so better you watch our previous session first for understanding this particular point. Okay, now as far as this session is concerning, here I just want to define what deterministic finite automata. Okay, now I want to give you a definition of deterministic finite automata. Okay, so see, deterministic finite automata is defined by using 5 tuples. Deterministic finite automata is defined by using 5 tuples. Okay, so here I just want to mention those tuples. Okay, first tuple is Q. Okay, then second tuple is sigma, input alphabet sigma. Okay, next tuple is delta. Okay, then next tuple is Q naught, or also called as Q0. Okay, and last tuple is F. Okay, what I am saying, this deterministic finite automata is defined by using 5 tuples. Okay, first one is Q, then input alphabet sigma, then this is called as delta, then Q0 and F. Okay, now I want to give you description of each and every tuple here. Okay, see here Q is called as set of states. Q denotes what? Q denotes set of states. Okay, then next tuple sigma, as we all know, we are quite now familiar with this symbol. Okay, this sigma will represent what? Sigma will represent input alphabet. Okay, and what is input alphabet? How to mention input alphabet? We have already discussed this particular point so many times. Okay, in our earlier session. So sigma will represent input alphabet. Okay, delta will discuss later on. Okay, so before that we'll just discuss Q0. So Q0 denotes initial state. Okay, and F denotes set of final states. Okay, now initially what I said, Q will represent what? Set of states. Okay, now I want to discuss this particular definition with the help of this diagram. Okay, in my last session what I said, this diagram is a diagram of what? DFA. And DFA, this is a DFA of which language? This is a DFA of this language L. Okay, and this language L represents what? This language L represents all strings starts with A. In my last session I have already told you that it's not the case like every time we have to draw same type of diagram. It's not like that. Every language is having its own diagram, own DFA. Okay, so this DFA is of this language, and this language represents all strings which starts with A. Okay, so when you change your language, then accordingly we have to change your DFA structure as well. Okay, but now I want to define this particular DFA with the help of this example, same language. Okay, so Q, for this particular DFA, what will be Q? Q, what I said, this is a set of states. Okay, so for this particular language, what will be value of Q? It must be a set, and set of what? States. So in my last session what I said, what are states here? A, B and C, they are called as what? They are called as states. So what will be value of Q here for this diagram? This is A, B and C. Okay, it's very easy. Okay, now next point. Second tuple represents what? Input alphabet. So what are the input alphabet that we are considering for this particular DFA? What are input alphabets? A and B. So what will be value of sigma for this language L, rather for this DFA? Okay, so what will be value of sigma? This is obviously what? Small a comma small b. Okay, then next tuple represents what? Q0. This is the initial state. Okay, if you remember, see, in my last session I have already told you that in every DFA there will be only one initial state present. In every DFA there will be only one initial state present. So which is initial state that is present in this DFA? How to identify that? What I said before, circle, if this type of arrow is there, then that state is called as what? This type of arrow means, see, this arrow is not coming from anywhere. Okay, otherwise you may say like here also there is a arrow. Okay, and then we may say that B can be also treated as initial state. It's not like that. We just cannot see, these two arrows are different. Okay, why different? Because this arrow is having source as well as destination. Which is source of this arrow? That is state A, and destination is state B. But unlike that, if we consider this arrow is having only destination, not source. So if such types of arrows are there associated with the state, then that state is called as initial state. And what point that you have to remember here is, you can draw any DFA, but in every DFA there must have only one initial state. So here only one initial state is there, that is E. So what is the value of Q0 here? And see, here this is not a state. Okay, so don't write it. This is not a set. Okay, so don't write it in curly bracket. Now alphabet is what? That is a set. We have mentioned it in curly bracket. Q, what they mention? Set of state. So this is state, that's why here curly bracket. But Q0 is initial state, that is not set. So directly here you have to write what is the value of Q0? That is A. Okay, now last, second last. Okay, next tuple, that is F. F represent what? Again, set of final state. So it is a set. So if it is a set, then as we all know, we have already studied this in discrete structure. Okay, if it is set, then we have to write it in curly bracket. Okay, so F represents what? Set of final states. How many final states are there? How to identify? What I said, if there is a double circle, if circle within circle is there, then that is called as final state. Okay, so how many such structures are there? Only one such structure is there, circle within circle. Okay, so B is what here? B is final state. Okay, so what will be value of F? That is B. Okay, here it is B. Okay, now see, this is a set. So as far as this DFA is concerning, see, in this DFA only one final state is there. Okay, sorry, in this DFA only one final state is there. That's why I have just mentioned only one element in this F set. But sometime in some other examples you may get a requirement like there may be more than one final state present in single DFA. You have to remember this point. In this example only one final state is there, but it's not the case with all DFA. In some other examples requirement may be like that particular example may contain more than one final state in it. Okay, getting my point? Related with initial state, what I said, in any DFA there will be only one initial state present. Okay, and as far as final state is concerning, it some DFA may contain only one final state, or few may contain more than one final state. Now I hope this point is clear for you. Okay, now let us proceed with last tuple. Okay, this tuple is important. Okay, before that you just revise this, because I am not having sufficient space on board. I have to erase this particular point, okay, for better understanding of this delta. Okay, so Q set of state, alpha sigma input alphabet, Q0 initial state, and a set of final state. So everyone's values I have mentioned for this DFA. Okay, now I am going to erase this. You can make a note of all these things. Okay, don't just watch, you can copy it in your notebook. Okay, now let us discuss last function. Okay, that is delta. This is a Greek letter, delta. Okay, what delta represents here? Delta is a function from Q cross sigma tends to Q. Now this point is slightly complicated for understanding. Okay, for understanding this particular point, you have to take a reference of prerequisite, as I said earlier, discrete mathematics. Okay, so how to find cross product and all you must know. Okay, so we'll revise it. Okay, we'll just start with basic. What point you have to remember? Delta in DFA, I'm talking about definition of DFA. Okay, in DFA, delta is a function from Q cross sigma to Q. Now what is meaning of this statement? Q means what I said in my last presentation. Q represents set of state. So what are the values of Q that we identify for this example? How many states are there? How many states are there? 3 states. Okay, so A, capital B, capital C. Right? This is value of Q. Okay, for this example. And what here in between cross product we have taken. Okay, and then input alphabet sigma for this example. What is value? A comma B. Okay, so here a comma small b. Okay, and then its result, what they are mentioning according to definition, its result must be Q. And what is Q? Q means what again? A, B, C. Okay, so before proceeding with the right side, let us first solve left side of this one. Left side. Okay, then we'll discuss right side. Okay, see, this is cross product. I hope that you still all remember, okay, how to find the cross product. It's very easy. Cross product, if you want to solve this, how to solve? See, first combination, you have to take first element from first set. Okay, capital A, very easy. And then combine it with first element of second set. Okay, so A. This will be first output. Okay, then again first combine with second. Okay, so here A, B. Okay, so this is output of these two. Okay, and then similarly just take down next element B, then small a. Okay, then B, then small b. Okay, and then C, small a. Okay, and finally C, small b. Okay, this is what? This is output of these two. Okay, and on right side, what they mention? On right side means everyone's right side. On right side, there must have what? Q. And Q means what? Q means here again what? A comma B comma C. Means one of the all three values there must be present. Okay, so how to find out right side of this? See, you have to observe this diagram. Okay, whenever you are in capital A, in state capital A, if you observe input small a, then what will be resultant state? That is capital B. Okay, very easy. Whenever you are in capital A and if you observe small b, then what will be resultant state? That is C. Okay, whenever you are in capital B, okay, if you observe A, you will be in B only. Whenever you are in capital B, if you observe small b, you will be in B itself. Okay, similarly, whenever you are in C, observing A, you will be in C, and whenever you are in C, observing B, you will be in C. Okay, so this particular part is nothing but this side, left side. Okay, and right side will be any one value. Okay, so how to elaborate this, getting this point? Transition function delta is a function from q cross sigma to q. Okay, so q cross sigma means this column. Okay, and next q means any state, so this column. Okay, so I hope now you are getting what is delta. What is delta? Okay, I repeat, q is what? Set of state, input alphabet sigma, then transition function delta, whose definition is given like q cross sigma tends to q, and this is the explanation of that one. Then q0 is initial state and f is set of final state. Okay, now see, in my last point during classification, what I said, there are various types of finite automata. Okay, so this is what? This is deterministic finite automata. We have started with deterministic finite automata. Then what I said, there is NFA as well. There is a NFA with epsilon is also there. Okay, so see, from automata to automata, only there is a difference in this particular tuple, in delta function. There is a difference only in delta function. Otherwise, in DFA, in NFA, and in NFA with epsilon, these four tuples are common. There is a difference only in delta. So for DFA, delta is defined like this. For NFA, some different definition is given for delta. Again, for NFA with epsilon, some different definition is given. But in all, DFA, NFA, and NFA with epsilon, first four tuples, that is q, sigma, q0, and f, will remain same. Point is slightly complicated for understanding. Okay, but if you concentrate on this particular topic, then I think you will not find any difficulty. Okay, so in this session we have discussed two different points. First one is classification of finite automata, and then we have discussed definition of deterministic finite automata. So how to write definition? DFA is defined by using 5 tuple. Then you have to mention all 5 tuple, and then you have to write description of all with the help of example. So this example I have mentioned. Okay, if you find any difficulty in understanding any point, then you can ask your queries through comments. Otherwise, you can ask your queries through our official WhatsApp group as well. Okay, so that's all for this session. Stay tuned for further updates. Thank you.